A little bit about me, 20 years in IT, specifically in InfoSec. I have worked in oil and gas specifically the last 10 years. My parents actually were independent natural gas producers, so I literally did grow up on rigs and at well sites and at production and on the mud pit and things like that. So that's really where I kind of started off. Along the way, I've done penetration testing for federal civil, federal law enforcement, state and local government, as well as private industry, vulnerability assessment in those same groups, network architecture, design, and implementation. That was part of one of my favorite gigs. That was 5.5 years building an oil and gas company's network security, from the switches all the way to the users, applications in between. And then kind of how that all rolls up is in the risk assessment realm. And I'm sure a lot of folks here understand how risk assessment is composed of the technical controls, the administrative controls. We're going to focus today a lot on the technical controls, but I do want to make point for the administrative controls as well, because you really can't have one without the other. So what's the problem here? The problem is, first off, you have legacy equipment and communications equipment. So what does that mean? That's actually legacy in ICS and SCADA can mean 30 years or older. I had a client I went to first part of this year where they were running PLCs, so programmable logic controllers. Those are extremely simple computing platforms. Very low power processors, very low clock rate, very little memory. You've probably heard of Modbus before. It's one of the first industrial protocols standardized upon. These PLCs were still in use, operating pipelines. These were Modicon PLCs. These are the PLCs that they wrote Modbus for. They invented Modbus to talk to these PLCs 30 years ago. They're still in use today. So legacy really does mean not just, Windows Server 2003 or a 5-year-old Dell. This is 30-year-old equipment. So remote geographic connectivity. Remote for a lot of IT people, and just kind of as a backpedal a bit, this is primarily for an IT audience or a corporate IT audience, enterprise. But I do also want to make sure that I don't leave out any field personnel or field-focused personnel that are interested in this. So if you're IT, this is geared more towards you. If you're field personnel, these are what the IT people need to know when they work with you and how they can interact with you. So remote connectivity is not VPNs from the hotel. Remote connectivity is 80 miles in the Gulf of Mexico in deep water. It is 500 miles from the nearest office building where you can get a T1 circuit dropped. Remote is in the middle of a backwater up in Mississippi somewhere where you don't have line of sight for satellite communications. So remote truly is remote. Usually in InfoSec we talk about the CIA triad, the confidentiality, integrity, availability. InfoSec focuses primarily on confidentiality and integrity. If the data is not available for a period of time, it's bad, but it's not as bad as if it's been compromised or breached or modified. On the ICS, SCADA, or OT side, operational technology to use Gartner's term, availability is key. If the data is incorrect, the next time you pull it, it'll pull the correct data. If the data has been modified, same thing. You're going to repeatedly pull this data back in again. If you can't get that data for 5 minutes on SCADA, it's an alarm. If you can't get that data in 5 seconds for a control system, that could be a safety issue. That could actually be a health and safety problem. Power and space is at a premium. Again, air-conditioned, card key access rooms, availability of 220, 110, 3-phase on generator, things like that are usually not what you find for industrial equipment. Chances are you're going to be in a watertight NEMA container. Maybe you've got a 12-volt battery with a transformer. You're running things at 5 volts or even lower. You may have a solar cell on the top to actually recharge that battery. So things that draw a lot of watts and in like form factor for data centers and racks, don't really fit in here. A lot of times physical security is used as the catch-all. Excuse me. So you go out to a substation that has, maybe they have a fence over it. You jump the fence, there's an unlocked Windows XP machine inside an unlocked door connected to all of the other substations and all of the meters downstream from it. You go, well, that's a problem. You know, anybody can just jump the fence and get in. Yeah, but we have a fence and we have a camera and we have a guard that comes by every 6 hours to make sure that nobody's supposed to be messing with this. So that's their considered compensating control. So a lot of times when you deal with the industrial side, physical security is what they fall back on rather than information security or cybersecurity. Life safety is involved, and sometimes it's dependent upon OT technology. Now, health, safety, and environmental, HS&E, is a primary concern for all industrial environments that I've been working in. The first time you show up to a facility, you go through an HS&E briefing, that you understand what hazards are at the facility, you understand where to muster, what the different alarm sounds mean, where you go. So a lot of that depends upon the safety PLCs, the safety equipment being accessible at all times, being able to connect to all of the remote sensors, the sniffers to look for toxic gas concentrations, things like that. If you have an incident, an OT incident that affects the availability of your HSE controllers, your safety, or your safety instrumented systems, SIS, then you've got a serious problem. You've actually got life safety concerns riding upon that Ethernet connection if that's how they're connected. So what it boils down to is that the demands placed on industrial control systems and SCADA networks don't often meet up with proper security requirements. And that's really what we're all here to talk about today, is what are some meaningful security requirements, what are some meaningful security implementation that you can apply to secure these systems. This is a screenshot of the Sonora gas fields in Texas, mile marker 400 on Interstate 10, a company I used to work for. I actually helped build some of the interconnections there for that. So when we talk about remote connectivity, this is your environment. So each one of these little white spots here, those are actually well pads. You've got one or more pieces of well equipment on there. You've got flow meters. You've got plunger lift controls on well heads, on like the pump jacks that are going up and down. You may have control of those things. You've got sulfur monitors, sour gas monitors for H2S, hydrogen sulfide. Big problem out in West Texas. So each one of these little white pads here has 1 to 10 devices that may be network enabled and communicated with for ICS and SCADA. So I can tell you that there is one piece of fiber that runs from San Angelo, Texas, down to the Mexican border. That's it. That's the only wired connectivity that this region has. And this particular region is about 30 miles as the crow flies from that piece of fiber. So the cost to build out a wired infrastructure for this is astronomical. I mean, in the tens of millions of dollars. So we set up wireless radio networks. So each of these areas has a series of wireless radio towers running on different frequencies, different bandwidths between 900 megahertz at about 1.5 megabit, or about 750 kilobit, up to 45 megabit for the long haul connectors here. And this over here would be the office. This is where the fiber actually does terminate. We were very thankful to be able to get a piece of fiber to the office. And so you've got Ethernet that runs out to your radio. But out here, I mean, from this to this, all the way to the edge of the field is probably 60 miles. So it's not easy just to go outside and, oh, that system's not working right, let me just go physically walk to it and fiddle with it. No, that's an hour's drive. You've got gas, you've got overtime for your field operators. There's lots of concerns here about just keeping it, operating on it, remotely. Over here, let's say this is Houston or Oklahoma City or Denver or whatever city the company's headquartered in. Over here, you've probably got high bandwidth, low latency connections, OC3s, special area Ethernet, things like that. But you also have satellite backups. And in some cases, depending upon where you are, that satellite is the only connection you're going to have out. Especially if that one piece of fiber that runs from San Angelo to Mexico goes out. Because trust me, I've driven the entire length of it. It's only underground for about 80 miles. After that, it's up on telephone poles all the way. So somebody swerves off the road, takes the pole down, you're down for a day to 36 hours. So satellite's your only way out then. So first steps, what are the first things you want to do? You've been asked, let's just say you've all been asked by your VP of IT or CIO, someone like that, say, hey, I want you to go talk to the field personnel, the SCADA people. I want you to understand their needs, and I want you to help them secure. So first off, understand the network and the data flows. You may know your enterprise network well. You may have good documentation. You may have automated scanners that run that map it out for you. On the OT side, they probably don't have that. They probably have exceptional wiring diagrams, power distribution diagrams, loop diagrams, P&IDs for understanding how the different valves talk to each other, but they may not have that. So the first thing you're going to want to do is go out there and assist them. You learn while they learn what their network looks like. What are their data points? What are their inflows and outflows? I'm very big on doing a data flow analysis. Now, to OT folks, to ICS folks, a data flow analysis is extremely detailed. They're talking about sending, I'm sending you 20 milliamps at 5 volts for 2 seconds from this valve to this meter. We don't really need that level of detail, but we do need to know that that meter is Ethernet connected. It's connected to this switch or this router or this wireless access point in some cases, and how that data travels from that meter back up to the engineering workstation, back up to the data historian, or whatever HMI, human machine interface. That's the fancy panels that they have that show you all the different, how the process is operating. So understanding that network and the data flows within it. This does not require the IT people that are assisting to be experts in this stuff. A lot of us are IT background. That's kind of what we came up as or whatever. Maybe we had a little engineering along the way. Maybe we had some industrial technology along the way. But this doesn't require us to be experts. I don't have to know how to program that PLC over there, and I don't have to know how to fix that valve when it breaks. That is completely their job. So don't be overwhelmed by the fact that you're not an expert in this area. Start with the basics. Again, data flow, drawing out diagrams. It can be a whiteboard session. It can be pieces of paper. I went to a client a year and a half ago. I sat down and talked with their engineers. And the next day, I had 8.5 by 11 sheets of paper with very well drawn out pencil drawings of their network. And that kick-started me to help figure out, okay, well, these are the core components. Now let's start spidering out from there and see. So, just go back to the basics. Go back to your initial network diagrams. Sometimes you can use the concepts you're familiar with in enterprise IT with modification. Again, we talked about kind of the inversion of importance. Availability being key, not confidentiality and integrity. So enterprise IT, you're going to focus on confidentiality and integrity. So again, understand that some things like patch management, antivirus, network segmentation, demilitarized zone, DMZ, things like that that we eat, sleep, and breathe are different for the OT folks. And we need to understand that we can't just go and go, oh, I'm just going to segment your network here. I'm going to put you on a monthly patch cycle on Patch Tuesday. I'm going to do all of these things. That's going to cause serious problems. Really important thing is to build the relationships between enterprise IT and industrial IT. As the first person to go out and talk to the industrial IT folks, there's going to be a lack of knowledge. Each side is not familiar with what the other side does. And so that can build some tension between the groups when you go out and talk to them. So just understand you're going to have to put a lot of that aside and build those relationships. And sometimes you're the person, sometimes the boss comes in on Friday and go, hey, guess what? You're the new liaison with the industrial IT group. I'm going to need you to go have a meeting with them Monday morning, get out in the field, and come back by the end of the day with report on what all they've got. That would be really great if you could do that. This is going to be our test, this is our basic environment. Extremely simplified. The key points here is that you've got what I'm calling the production network. Production network being the industrial side. Okay. You've got a PLC down here. You've got data points, I/O, fire panels, facility access rooms, gas sniffers, toxic gas sniffers. You've got an engineering workstation. Okay, an engineering workstation is typically just a Windows workstation with maybe $20,000 in specialized software on it to control and manage these PLCs and these endpoints. Okay, yes?
For example, on those server workstations you were mentioning, I mean, could you please elaborate on why integrity wouldn't be that essential?
So the integrity of those systems actually is very important. It does tie along with the availability of it. Integrity of these data points down here can be replicated, can be picked up. So suppose you have like a bit level error in a polling cycle where you're polling from here to here. That kind of data will get picked up again, but you are correct. If you have a configuration file on your engineering workstation that gets corrupted, integrity is very important.
Or reading the wrong monitoring information that I make some wrong decisions.
True, yes, that is definitely a good point. On the operations side, they would probably consider that more availability than integrity because it takes the process down. But you're very correct in that it is important. And you know, whenever I'm saying confidentiality and integrity is not their key point, it's not that it's off the radar for them. It's just that, number one, it has to be up. It has to be live and it has to be talking. If it's not, that's job one. That is the process, whatever process you're doing, if you're making chemicals, if you're producing oil and gas out of the ground, if you're building a car, or if you're washing produce on a food line. That is the most important thing. The integrity of the data as it comes through there is important, but that's secondary to the availability of it. Right, so you've got your engineering workstation, Windows XP workstation, maybe Windows 7 if they've upgraded in the last 3 years, but probably Windows XP, running about $20,000 worth of software from Siemens, Emerson, GE, take your pick. Because it's so expensive, you're not going to have a whole lot of these laying around. You're not going to have this installed on a Citrix server somewhere so that multiple people can remote into it. A, you're not going to have a Citrix server in this environment to begin with, and B, the vendor's probably not going to want you doing that for licensing concerns because they want to get their money too. And over here, let's talk about this machine up here. This is a third-party monitoring and control server. Extremely common. So you've got a vendor, let's say you've got GE. Say you've got a GE turbine as part of a generator making power. GE is going to want to be able to connect into that system that talks to the turbine over here 24/7. They want to be able to make sure that, oh, hey, this person over here just figured out that there could be a problem with these generation turbines running in this load with this fuel and this vibration, etc. Let's do a quick poll. They're just going to connect in without letting you know. And if you cut this connection off, you don't have support anymore. They're not just going to come out. They're going to go, no, we're not going to do it. Turn it back on, or we're not going to support you. And then over here, you've got your handoff point. Maybe that's a switch or a router. And then over here is your business network. This is going to be your IT network. This is going to be where your email sits, where your ERP system, database, users, things like that. The key point here is there's just a connection. There's just bare wire there. There's no firewall. And this is how a lot of industrial systems are connected currently. People are making great strides. I like to think of industrial IT, industrial cybersecurity as being about 15 years, 20 years behind what enterprise IT is right now, just because of the maturity from the last 15, 20 years. Again, there's always exceptions. I mean, I've been to clients that have, when you look at the very end of my slide, they've got everything segmented out. everything monitored, but just be aware when you generally go into ICS environments, this is what you're going to see to begin with. Let's talk about what do you need to do. So first off is network segmentation. This is creating separate network zones, we're going to go into that in a second, that prevent systems from talking outside of their own zone. Things like DMZs and enterprise IT, very common tactic. They need lots of DMZs in the industrial side, or just different network segments. You need to worry about portable media control. Thumb drives are a primary mechanism for data transfer in industrial IT. One, because a lot of times their method of security was air gap, right? If you don't physically have a connection between these two networks, it's secure. Yeah, but I've got to get a config from one system to 50 systems because they don't talk to each other. Well, I'm going to plug in a thumb drive, copy the config to it, and go to I'm going to sneaker net to each of those 50 machines and copy it over to it. So portable media control is very key. Your vendors are coming in to update software on your PLCs. They're probably going to come in with a thumb drive or an external hard drive and load it directly onto it from their laptops that they want to connect to your network without anything stopping them. Configuration management, ensuring that all of your industrial IT devices are configured the same way. So again, very common practice in enterprise IT. You've got a configuration management database, a CMDB out there. Maybe it's pulling nightly, pulling switch, router, firewall, WAP configs off. Again, not happening in industrial IT at the moment. So be aware, you're going to have irregular configurations from switch 1 to switch 2. They're just going to vary. Patch management, big concern. I'm going to go into this in a minute, but basically you've got systems in industrial IT that haven't been patched in years, maybe even since it's been commissioned. And there's lots of reasons for that. The primary one being they are dependent upon the software and the hardware in the field for the availability to happen, right? For the process to work, you have to have the hardware and the software talking to each other. The software and the hardware may be 10 years old, 15 years old. The software, the company may not even exist anymore. It may just be, like kaput. It's good hardware, it's good software, but there's no support for it anymore. So what happens when you patch against the latest IE use after free vulnerability? Or if you patch away in how Windows SMB communicates, SMB signing, things like that, you break it. You have nobody to support you now. And even in software that is currently supported, that you buy from Siemens and Emerson and GE, they're going to tell you, we're only certifying that this software will work at this OS level with this patch level. If you deviate from that, we're not going to support you, or we're going to make you roll back to the version that is supported. So patch management is a crucial issue both for the IT side, but the OT side as well. Disaster recovery planning, as important as it is for IT, OT is the same thing. So you're going to see a lot of the same topics that you generally see when you talk about security best practices that goes across IT and OT, but again, how you implement them is different, and some of your concerns are different. Workforce development and training. It's very easy to pick up Global Knowledge Catalog, flip through, hey, I need to get trained on this software, this technology, this methodology. Not so easy when I need to get trained on how do I segment SCADA networks, how do I deal with high latency, low bandwidth connections, or software that needs to poll every 10 seconds. The general availability of that kind of training is not nearly as prevalent. And so again, this looks the same. These all look like the same kind of things that you deal with day in, day out on an enterprise IT network. But the implementation is the big difference. So again, if you try to secure your ICS environment like your IT environment, you're going to have a bad time. That boss from a couple of slides back is going to be very unhappy. And the field operators are going to be very unhappy. You're really going to have just a very bad time. So let's talk about the Purdue model. Anytime you speak of network segmentation, network protection for industrial control systems, you're probably going to hear the Purdue model or the Purdue Enterprise Reference Architecture. This is widely accepted within ICS industries, things like that. In fact, it's been written into some of the industry standards, ISA 95 and 99 for the International Society of Automation, as well as the newest IEC 62443. That's ISO 99, some NIST documentation. It's actually a really good document, kind of expensive, but it's actually, if you're building a framework to secure ICS environment, this is going to be your golden roadmap, this thing. So the Purdue model is integral with any fundamental way of securing ICS and SCADA. And it has two important concepts. It has the zone concept and the conduit concept. Zones are groups, are systems grouped by functionality, purpose, access level, however you want to do it. Systems within the same zone should be able to talk to each other with nothing in between them. No ACLs, no firewalls, or at least if there is, they need to be open, But usually zones are at a layer 2 level, maybe layer 3, but pure connectivity between them, nothing stops. A conduit is a mechanism by which you go between zones. Firewalls, routers, things like that are considered conduits. They let you travel between different zones based on the rules that you create, the configurations that you. To make it really confusing, they represent it by levels 0 or 1 through 5. So it's very easy to get caught between the OSI model for networking and the Purdue model. But we're going to talk about layer 0 or layer 1. Layer 1 being the first IP addressable system that you are generally accessible. You can get to it via console, terminal, physically connecting to it. Layer 0 could be the equipment itself, the valve, the meter, the alarm system, like whatever, all the way up to 5. And I'm going to have a nice diagram here to show you kind of the progression of that. The Purdue model is the starting point for ICS network segregation. And again, it's a model. Your implementation is going to vary. But look at this as, this is how I should start looking at these things. Talking about zones again. Traffic between the same zones is implicitly allowed. If you put something between it, you now have 2 zones with a conduit between them. You don't have 1 zone anymore. Traffic passing between your zones, again, is facilitated and controlled via the conduits. The conduits tell you whether or not you can pass between these 2 zones. The layer 2, or L2 on Purdue, can set and change values on the levels beneath it, L1 and L0. That's the important distinction. When you look at how do you define something, is this level 2, or a layer 2, or a layer 3? Layer 2 can set and change. Layer 3 can only read. So there's something preventing write control between once you get up the layer to L3. When you're at L2, you can change. When you're at L3, you can only read. And anytime you have a conduit, anytime you have a control point, that is a point to let you report, monitor, and alert. So the conduits are not just to control data flow, but also to let you know what's happening on your network. So don't just think that a firewall is just there to be a firewall. No, a firewall should also be able to give you maybe net flow information, or at a minimum, SNMP about how much traffic is flowing between your interfaces. So here is the pretty Purdue model that one of my former coworkers made. So starting down here at level 1, you've got the PLCs themselves, hardwired instrumentation, and in this case you also have the SIS, the Safety Instrumented Systems. These are your safety PLCs that are designed to operate safety controls, fans, alarms, alerts, pull data from sniffers, things like that. A lot of times they're made by the same manufacturer of the basic process control PLC, but you pay more for them because they've been certified to do things at a higher level, but it's usually the same hardware. Sometimes they're on the same bus. In this example, I think it's better you have them on separate control buses so that any kind of failure in the basic process, the BPCS is the basic process control system. So that a failure in the BPCS bus does not keep the SIS from functioning. So in this case, we have them separated here. So yeah, here's your L1. and going up into L2. Now you notice there's a delineation here in color, but there's not network-wise. L1 and L2 can see each other all day long. They can pass data up, and they can push changes back down. Here's your engineering workstation that has the software on it that can modify the configurations of the PLCs down here. Here's your HMI. That's your touch screen maybe, so that your operators can turn off and on valves that have been predefined via the set points from the engineering workstation. And then again, here's your safety engineering workstation as well. Now it's connected only to the safety PLCs, and again, they may even be on a separate air-gapped network. Just depends on how it's all set up. Interesting thing here is you've also got the third-party systems. We'll talk about that in just a second. But now you're going to cross into L3. You're going to go from supervisory control, again, set and change data points, to operations management, read-only access to systems. That's where you've got maybe your OPC server, your OLE for process control, Microsoft protocol that allows you to basically just stream data from any system and you collect it on an OPC collector. Historian, which is a database for SCADA or control system data up there. You're going to have all of your flow data is going to come up and probably land in a historian somewhere. Sometimes you may have an operations historian down here too, but closed circuit TV, physical security sometimes comes in on the same system because there's some parallels between physical security instrumentation and industrial control instrumentation. The important thing here is that going from L2 to L3, you're passing through the control firewall. You get into L3, you go up to L4, now you're entering enterprise systems, you're entering IT's realm. And again, you've got another firewall here. Usually you'll find that, when you have a segmented Purdue network, a lot of times, the operations people manage the control firewall, or at least dictate how that control firewall is configured. IT controls the enterprise network firewall up here between the corporate and the plant side. Again, with instructions from operations usually, but generally OT owns this one, IT owns this one. L1, L2, there's no firewalls there. Third-party systems. So anytime you have an industrial control environment, you're probably going to have a third-party system. Depending upon what process you're running, maybe this is nitrogen enrichment for something. Maybe this is vibration management for a turbine or for a propulsion system. Maybe it's a solar generator for a platform. So you're going to have these third-party systems that are not under your company's control. They are vendor-provided, vendor-owned, vendor-operated. They need to sit on your network. They need to have direct level access to your PLCs, your engineering workstations, your historians, things like that. So that right there is going to be a key component of how you segment and operate your network. And again, those are your key firewall points. We've taken our initial diagram. Now we've kind of cleaned it up some. Now we do have an initially segmented Purdue network. So L4 and 5 is over here. That's all IT. Between the operation switch router, you've got your DMZ firewall. This firewall could be between these two. It just depends on your network architecture. But basically, you have an L3.5 firewall between enterprise and OT. That gets you into the historian, the L3 over here. Now you've got an L2.5 that prevents you from connecting to the engineering workstation, the HMI. At this point, the third-party monitoring and control does go into here, as well as the L1 and L0, where you've got the PCN firewall for the RTUs, the PLCs, things like that. Note here, though, now a third-party support company is landing on this DMZ firewall. So you're going to have to facilitate that somehow, whether that's a separate circuit, whether that's hopping through DMZs, just depends. But basically, we're removing this direct connection point up here to the third-party monitoring box and dropping it into that DMZ firewall. Let's talk about firewalls. ICS applications often misbehave with respect to traditional client-server enterprise software. OPC, Object Linking and Embedding for Process Control, an acronym of an acronym, OPC, uses MSDCOM. If you've ever done anything with networking and Microsoft's DCOM model, it does not communicate statefully. It's UDP, And it requires you to open ports 1024 through 65535 bidirectionally. You can't stop it. So anytime you deal with OPC, you're going to have ugly firewall rules. You're going to take a pretty firewall and you're going to punch a lot of holes in it for little things and this one gigantic gaping hole for OPC. The protocols themselves that the industrial systems communicate on have been subverted. Modbus just has no functionality for authentication, for validating that a command that you pass it is valid or is proper or anything else. DNP3, which is an open standard heavily used in electrical generation, has protocol level vulnerabilities as well, to the point of you can set values outside of the maximum and get unexpected results. You know, things like a use after free vulnerability that Julian was talking about, you can do that at the protocol level at DNP3. Now they are working on it, but understand that the protocols themselves are not going to save you. Some vendors have started to adapt, some firewall vendors have started to adapt to the ICS environment. Tofino and MGuard are two very well-known industrial firewalls. They run on 5-volt DC, they're running rail mount, they're running in an OSHA classified environment, meaning that there could be explosions possible or fire possible based on the atmospheric conditions. So you do have some firewalls out there that are designed for ICS. Palo Alto has started an ICS firewall, currently rack mount only, but it does have some ICS support built into it at the protocol level and the signature level. So just understand too, your firewalls in an ICS environment are going to take longer for tuning and testing purposes. You can't just throw your standard use case, can I browse the web, can I check email, can I print, can I send a document type stuff. They may have to run in monitor mode for a month or a quarter, depending upon how often your processes need to be changed, updated, things like that. So expect to have them run a while before you lock in those configurations. Now let's go to host-based security. So USB and removable media control. Again, this is key. People are going to be trying to pass files, pass configs, pass logs even on USB devices. So whatever technology you currently have to monitor, control this, you're going to want to look at implementing that in your ICS environment as well. Whether that's whitelisting a brand of USB scanner. There's tools out there. Norman, I think, was bought by Symantec, but it was the Norman Shark product. Actually has a agent that sits on every workstation. You actually have a wall-mounted PC on it with a whole bunch of USB ports on it. And you take and you plug your USB key or your USB drive into the panel. It scans it, writes a signature against the entire disk, and then you take it out, you plug it into your engineering workstation. The Norman agent validates the signature hasn't been modified, and then it allows you to run from it. Great concept, except if you're writing anything to that USB drive, a log file, an INI file, a result file that says, hey, everything's good, you've just changed the signature file. You have to take it back up to the Shark panel again, rescan it again. So depending upon your use cases, understand the technology may not be effective for that particular system. Antivirus, anti-malware. Antivirus is 30% effective when you have current, up-to-the-date antivirus definitions. It's just not a valid primary security control anymore that can stand on, by itself. Anti-malware, better success rate, but only against malware, not against worms, trojans, things like that. So just understand you need it, but don't rely on it. Application whitelisting. This is getting a lot more publicity in ICS these days. Bit9 and Carbon Black, they are advertising. They are heavily going into the ICS space, saying, hey, we can go on your platform, we can go in your processing facility, we can operate ICS safely. There's a handful of others, Industrial Defender that was bought by, I think, Lockheed a couple of years ago. They're very big in the application whitelisting space. But application whitelisting is rapidly becoming a primary security control for these systems, mainly because they're very easy to profile. These are not like an engineering workstation you're going to run a handful of engineering software on it, control software. Maybe you use a web browser to access a handful of HMIs on devices, but you're not going to be browsing, you shouldn't be browsing the web on these systems. You shouldn't be doing your taxes on these systems. You shouldn't be installing applications every day. So this is actually a very good use case for application whitelisting because the environment doesn't change nearly as often as a general purpose workstation does. Group policy and workstation hardening. Again, similar concepts to enterprise IT, just done a little differently. You're probably not going to be able to enforce screensaver timeout of 5 minutes with a password required to unlock it again. You push that out to an HMI, after 5 minutes, all the displays in the plant go blank, and you've got an incident. So understand, you can use group policy to push out your configurations, to make sure your configuration management is the same. You can harden your workstations. You can do, restrict the number of types of applications that are run. You can use whitelisting on Internet Explorer or the browser, but just don't use the same group policy you do for enterprise workstations as you do for engineering workstations. Microsoft EMIT. This is one of my personal favorites. I love EMIT. Every Windows machine I run, virtual or physical, has EMIT on it. It's not a silver bullet, and if you're running software that gets compromised, if somebody successfully runs an exploit against it, you're going to kill that process. It's going to shut down, but you're very likely not to be compromised again. You can relaunch the application, make sure that whatever you're doing before has not compromised the system, and keep going. So EMIT is actually a really good tool. Again, takes some tuning and testing depending on the application, as well as can your process support if an EMIT protected application gets killed because of it, can your process support that? If it can, then I recommend looking at that as well. Your gold images, so your standard by which you build systems. You've got an enterprise IT, you're going to have lots of them in industrial IT because you're not going to have a general purpose workstation. You're going to have an engineering workstation. You're going to have an operations workstation. You may have an HMI system. So just understand, you should build the gold images to the proper patch level, the proper configuration that the software requires. You're just going to have a lot more of them than you do on the enterprise side. So patch management, number one field personnel worry. So a client a year and a half ago was talking to their building management department. This is the group that handles steam distribution to the entire facility. This is the group that manages energy, electrical distribution, including load shedding in the summer. So critical, crucial systems. Every single month, they had to roll back their servers. Every month, IT, they were in a WSUS collection group. They got patched on schedule by Patch Tuesday. And on Wednesday, they were rolled back because the software shut down. The software it wasn't a case of the vendor wouldn't support it. It crashed the software. So there was no other choice but to roll it back. That was every single month until we started talking about separating those security controls. Like I said before, vendors must certify or approve these OS level patches, configurations because of compatibility, because of conflicts, maintenance issues, things like that. So just because Microsoft says this patch is safe doesn't mean Siemens is going to agree with them. Again, there's no scheduled Patch Tuesday for ICS environments. I'm not aware of any vendor that has a monthly patch cycle for their ICS software. I could be wrong, I just haven't seen it yet. And in some cases, you can't just go to their website and say, hey, how often do you patch your systems? Some companies will put them out maybe quarterly or twice a year. Some companies may do them once a year. Some companies won't tell you when they patch unless you have a current maintenance contract with them, with a customer ID and everything else. So not only can you not download the patch, you don't even know the patch exists. So in this scenario, testing environments, QA environments, as well as the procedures for how to operate those are key. Again, you may not need to build up the actual PLC environment. You may not have to buy a lot of expensive hardware for a test environment. There are virtual PLCs out there. There is one written in Python that you can fire up in anything that runs Python, and you'll have a very basic PLC equivalent to probably a $500 unit if you were to buy the hardware for it. So you can virtualize PLCs if you want to mimic the inputs and outputs to make sure that the software that you're testing on the Windows or the Unix or the Linux side is functional. So understand, you can create a test environment without breaking the bank on hardware, and you really should be able, if you have any touch points into the support for patching, you really should have a dedicated ICS environment for that. But again, the procedures for patching and testing must follow business processes. The folks up here that monthly, thank you, are having problems with that, they're not matching the processes. And I have talked way too much, so I'm going to blow through these last few slides. I'm very sorry, so I can try to get some questions in at the end. So patch management, engineering workstations and servers, those are Windows boxes. You've got to patch those carefully. Again, corporate IT has these systems, but ICS can't patch it as often. They may not be willing or able to create new collections or timing on that. The application and the operating system security models are different between ICS patching and IT patching. And a lot of times depend upon Active Directory services. So what's the answer? You can actually build your own. Now we're going to look at my model again, and now if you notice here, we've added some security here. We've added IPSs to our DMZ firewalls here. We have actually created a whole new, we've expanded the little L3 here for the production network for the L3. We have AV update, we have domain controllers, we have a patch WSUS system. So we actually have created an infrastructure specifically designed for patching and managing ICS environments. I know that those exist over here, and in some cases you can use the business network for that. But depending upon how willing and how much time the IT people have, they may not have the time to support two environments. They'll support theirs, and then you'll support yours. And again, application whitelisting and USB device control on your engineering workstation. Third party and remote access. This is key. As I showed before, third parties are going to need to come into your environment and maintain their systems. Breaches have occurred because of this. Target being a big one, their HVAC contractor. Telvent, several years ago, Telvent had software at all of the super major oil and gas companies at the field level. The attackers, presume China, but everybody blames China these days. So the attackers back then, instead of compromising Shell or Exxon or Total, they compromised Telvent, who had site-to-site VPNs to every production field that they supported. So they rode in on those site-to-site VPNs and stole data on how their operations were running. Again, a lot of times the vendors won't recommend a security architecture for you, so you can build your own, again, Purdue compliant. So now we've got a new zone down here in purple that's L3. That is your third-party remote access DMZ. You've got a remote access server up top there. Maybe that's a jump box, terminal server, Citrix, whatever flavor you like. Maybe you've got a software down here to specifically manage your hardware that lives over here. And again, you're now coming in to this from your third-party support contract, landing on that DMZ firewall. And if you'll note the bus here, the bus, this third-party bus routes to the firewall. It cannot communicate with anything else, L3 even, or L2 or lower because of that DMZ firewall. When this goes wrong, incident response. Randy's going to have a really good talk here right before lunch, I think right after this one in the other room, about incident response, and I think she'll agree, incident response requires data. You have to have data to do incident response. You need centralized logging, traffic analysis. There's free software out there like Logstash, Elasticsearch, and Cacti that are free or nearly free software. Security Onion is actually a Linux distribution designed to do monitoring and alerting. Again, an IT tool that works great in ICS, especially since it's read-only. Restoring PLC programming, this is a little bit off topic. Basically, You can't just connect to a PLC like you can a router, switch, and firewall and pull a config off in a human-readable format and store it in a database. These are binaries, and depending upon the vendor itself, the binary, you may not even be able to back it up. You may only be able to back up the config on the engineering workstation that wrote it. So understand that there are different concerns. There is ICS configuration management software. MDT and Siemens both make some. Some are for their only, I think MDT will do any vendor. I think Siemens may only do Siemens. But there is specialized software to give you a configuration management functionality for the PLCs themselves. Trainings and certifications, they are uncommon. However, SANS and GIAC have created there's two SANS classes now, ICS 410 and 515. They have also created the Global Industrial Cybersecurity Professional, their GICSP certification. I actually participated in the creation of this certification and took actually helped them modify some of the questions and took the initial test. This is a basic level cert. This is not something that if you get this, you're going to be able to run out and configure PLCs and fix valves and rewire stuff. This is the minimum amount of knowledge required for an IT person to safely and successfully operate in an ICS environment. So it's IT heavy, but it's also ICS heavy, and it teaches you best practices. So I could recommend the cert. I haven't had the SANS classes, but I have friends that have taken them and like them. Idaho National Laboratory, INL, is kind of one of the global touch points for ICS cybersecurity. They have a control system security program where you can go, vendors can go, test software, test hardware, see if there are cybersecurity vulnerabilities about it. They do offer training, both from the IT perspective, but also from the OT perspective. You can get that through DHS and the ICS CERT environment. They also do vulnerability analysis. If you're concerned that a piece of hardware or software has embedded vulnerabilities, you can actually have them work with you to test this out, to do some of the things that Julian was talking about, static and dynamic code analysis of the equipment and hardware. INL does things like that. And a lot of times what it does is it combines traditional InfoSec with ICS sensitivity. Disaster recovery. Similar, but different. A lot of times when you mention disaster recovery to an OT person, they're going to go, we have plenty of spares. I have a warehouse a block away that has spares for all my equipment. I can have a guy here in 2 hours. Great. Can you restore that engineering workstation in 30 minutes? Do you have a spare of all your configs and all your backups and all of your manual procedures and processes? Do you have a business impact analysis? Again, IT-focused control that needs to be exercised in the OT space. What happens when this engineering workstation goes down? Does that kill your process? Does that just kill your visibility into the process? Or does that just kill your environmental control? So understanding what are those impacts. And again, updating the list of your vital assets and personnel. You have to know what you have. You have to know who can work on that. Who's available to fix those things. Thanks. I blew through a few of them, but if you want to know more, DEFCON 21. I gave this talk at DEFCON 22 last year, updated it for lockdown. Thanks for giving me the chance to work on it again. 2 years ago, DEFCON 21, I did it. My former coworker's presentation from Black Hat 13, Out of Control demo. It's a great series of slides. There's a YouTube video that we recorded at my old company of them doing the demo live. So search for Out of Control demo on YouTube. It's about 40 minutes long. You can skip past my intro because it's useless. All of the cool stuff in it is by Eric Forner, and it's really neat stuff. These slides are on the website here for lockdown. I also have them on my personal website, so feel free. If you're interested in ICS stuff at SANS, as well as ICS training, links are there. I've got a minute for questions, but maybe a couple longer if we can go. So. Yes, sir.
So, if all of these 30-year-old PLCs that are actually doing the valve controls and stuff are still in play, and even if I put the Purdue framework and all these things in place, you're still taking controls from the radio devices that are unauthenticated, right?
So access to the network that, and just repeating.
So if I got USRP, right, and a Linux box and a 1-watt linear and GNU radio, how do we detect that stuff, right? If I stand 50 meters from the thing and start blasting it with my laptop. And
Sure.
1 watt linear.
Sure.
How does a PLC differentiate that between legitimate control traffic, and B, how do we detect that?
Right, so A, it's not going to, and it's gonna fall over, when you hit it with that much data. They're not designed to handle high bandwidth. High bandwidth to them is 10 megabit a second, so.
Oh, right, no,
But so.
record some traffic.
Sure,
I just
sure.
replay it.
Right, so yeah, you do packet capture and replay. The Purdue model, in that case, you're gonna want to separate your networking components from your control components. So you may not be able to harden that endpoint. The PLC itself will not be hardened. And you may not even be able to harden the radio it's attached to. You probably will, and in other clients, that's what we've done, is we've taken off the old school 900 megahertz free wave that has no authentication, no stuff, and put on a more modern radio front end to it. Your USRP can still DOS it, there's no question about that. Getting onto it, you can use modern radio controls to actually restrict access into that network. So you don't focus on the endpoint as much as you put as many layers of segmentation as you can on top of the communications framework.
Right on.
Cool. Anybody else? Yes, sir.
So when you go into, when you start a project like that, are you doing all this yourself, or do you have a whole team of people that have to control all these variables that you described?
Sure. So normally I usually lead the effort with a few personnel, but you have a very good point. You're not going to talk to any one person on the operations side that has knowledge of all of their field. You're going to talk to the instrumentation and electrical technician. Maybe they know all of the wiring layouts, where all the cable runs are. You're going to talk to a field operator that operates this one piece of machinery. So you're really going to go talk to many people to understand that whole environment, that whole organism that is the ICS environment. So no matter how many people my group has, I know we're going to talk to 5 or 10 times that many people to get that understanding, because again, there is no single point of knowledge across all of that stuff. If there was, they probably would need us to come in. Does that answer your question? Cool. Anything else? Thank y'all again for sticking with me. I appreciate it.